In this video, we're going to take a very quick look at how to actually go about finding an inverse function. So again, here's an algorithm that will help you in case you get stuck. This is a way that it will work. The equation for the inverse can be found by replacing the f of x with y, okay? Then interchange your x and y. Then solve for y. If this equation does not define y as a function of x, the function f does not have an inverse function. And we stop. If it does define y as a function of x, then it does have an inverse function. And all we have to do then is replace y in step 3 with f inverse. And then we verify by showing that the compositions both equal x. Let's start off with a linear example. Find the inverse of f of x equals 2x minus 7. So what I'm going to do is I'm going to change f of x back to y, which is the way we initially learned this. Then I'm going to interchange x and y. My y is going to become x, my x is going to become y. Then I need to solve for y. So I'm going to use the symmetric property of equality to move the right-hand side to the left and the left-hand side to the right. Then since they said plus 7, I'm going to say minus 7. And since they said times 2, I'm going to say divided by 2. Then I'm going to say, I think that is f inverse. I'm not going to box it in yet because I haven't shown it to be true. But I am then going to move over here and hopefully show it to be true. So I'm going to start off by finding f of f inverse. So that means I'm going to substitute f inverse in for x. So this is going to be 2 times x minus 7 over 2 plus 7. The 2's cancel, leaving x minus 7 plus 7, which is x. That means I'm halfway there because that x is what I was looking for. Then f inverse of f of x means that I want f inverse, which was x minus 7 over 2, but I'm going to substitute 2x plus 7 for the x. So here comes the minus 7 over 2. 7 minus 7 is 0, so that leaves 2x over 2. The 2's cancel, leaving x. Because both left me with just x, I know that this is in fact f inverse. Now for something that's a little bit trickier, let's look at a radical equation. Find the inverse of f of x as the square root of 2x minus 5. Okay, so I'm going to say, put y in the place of f of x. Okay, then I'm going to exchange x and y. Then I'm going to solve for y. So again, I'm going to use my symmetric property to change the sides so that my y is on the left. Then since that's a square root, I'm going to square both sides. Since they said minus 5, I'm going to say plus 5. Since they said times 2, I'm going to say divided by 2. So I think this is f inverse. Now to be sure, I have to check f of f inverse and f inverse of f. So f of f inverse first, just because it's a habit. So I'm going to take the square root of 2 times x squared plus 5 over 2 minus 5. The 2's cancel, leaving the square root of x plus 5, x squared, I'm sorry, plus 5 minus 5, which leaves me with the square root of x squared, which is that x I was looking for. So I am halfway there. So now I'm going to do f inverse of f, which means I'm going to say square root of 2x minus 5 and that was supposed to be squared plus 5 over 2. The square and the square root kind of cancel each other out. Negative 5, positive 5, that's a 0. Leaves me 2x over 2, which is x. So it does check. This is my inverse. Now I want to pause right here. It's not so interesting on linear because domain and range are always all real numbers. So I want you to note something. Here, my domain, okay, is where 2x minus 5 has got to be greater than or equal to 0 so that I'm not taking the square root of a negative number. So 2x is greater than or equal to 5, or x is greater than or equal to 5/2. That's my domain, okay? But look at my range. My range, this symbol means the principal square root, which means non-negative, okay? And I'm going to use y instead of f of x because that's what you're used to. So I'm going to say that in this case, y has got to be greater than or equal to 0. If 2x minus 5 is 0, my smallest possible value is 0. And then it just gets larger from there because they're all non-negative, okay? I say that to say this. This guy's domain, even though it's not necessary in what's stated here, is set of all x such that x is greater than or equal to 0. And his range is going to be x greater than or equal to 5/2. Now, to get a hint at that range, and I know range is where most people have their weakness, but look, the smallest possible value of a square is 0. So that would be, in fact, 5/2, and then it would just get larger from there. So this restriction on the domain is necessary because if I don't have it, what I end up with is something that doesn't work because of the understood positive principal square root.